What is force? When we push or pull something, we are said to have exerted a force on it. Force is something that can bring an object into motion from rest, or into rest from motion, or at least it wants to. Force can also distort or alter the shape or dimension of things. It can bend an iron bar, can break a stick, or can change the shape of a paper box. Force can be applied by animated or inanimate objects. A moving car hitting a tree will apply force on the tree and vice versa. Here, the car was animated and the tree was inanimate. A stretched spring exerts forces on the bodies attached to its ends. Here, the spring is an inanimate object, but can exert force. Force is a vector quantity. We can apply force to different directions, and the outcomes will be different for different values, as well as for different directions. These types of forces we have talked about up to now are applied with a contact. There are forces that can be exerted without any contact. Gravitational force and magnetic force are these types of forces. These forces can act through empty space and without any contact. If the force is applied through the center of mass of an object, it will create translational motion only. If the force is applied through any other points, it will bring in rotational motion as well as translational motion. Two equal forces applied on an object through the same point at the same time to two opposite directions will cancel each other. If the forces are applied in the same direction, it will result in a bigger force, which is double in magnitude. Forces applied to different points in different directions are a matter of vector mathematics. Force is represented by the letter F. Its dimension is mLt to the -2 power, and the unit is Newton, or N, that is derived from kgms to the -2 power, or kgf. We will discuss two methods to measure a force, and will define a unit force from these. Students are advised to follow both, as these are very important to understand the fundamental concept of force and its measuring techniques. If you don't get it in one go, give it a multiple try. Method 1. We said earlier that a force can change the shape or alter the dimension of an object. From our daily experience, we see that the bigger the force on the object, the bigger the amount of distortion. We'll use this property of force in our first method. Let's assume that we have a metal spring. If we attach one end of the spring to something and pull the other end, the spring may extend. The harder the pull, the bigger the extension. We will consider an ideal spring and will always stay within its elastic limit so that we don't overcomplicate the basic study. Now, let's fix one end of the spring to a wall, and let's set a pointer with it in a way that the pointer will move across a straight or circular scale according to the elongation of the spring. Greater elongation is accompanied by higher reading. Now, if we hang an object of 1 kilogram mass at the lower end of the spring will extend, and the pointer will move to a certain place on the scale. We know the spring was extended due to the force applied by the 1 kilogram object, and actually the object was pulled by the Earth's gravitation. Let's say this amount of force is force of 1 kg, or 1 kg force, or 1 kgf. According to the elastic property of the spring and Hooke's law, a 2 kilogram mass will double the elongation of the spring. The pointer will move farther than the previous place and will stop at a different position on the scale. Let's mark it as 2 kgf. This way we can keep marking greater forces like 4 kg, 10 kg, 20 kg, etc. Now, if we place the spring at a horizontal or any other position and pull one end with our hand, from the reading of the pointer we will be able to measure the amount of force we're applying. We'll consider the force applied by the Earth on the 1 kilogram object as a unit force, which is 1 kgf. This way we can measure different amounts of force. This is one method to measure forces, and we can define unit force from this. To know the second method of measuring force, watch part 2 of this video.